So we got that. Now we need to do the same thing for sign in. So let's do the same thing for sign in. So export const sign in, request response. Let's think through this. Create new user makes sense. We took the username and the password you gave us. We hashed that password. We got the user from the database, assuming it worked. Created a token from it and sent you back the token. How would sign in work?
So we have to get the token from the request header.
Nope, no token yet. Sign in, just like create new user, also issues a token. They're signing in because they don't have a token. Yep, so no token yet.
And just one question, like in the token, we are putting the user object, and user object will have the password, right?
It does, but we specifically said in our create JWT that we're only putting the ID in the username. Yeah. Yeah, we passed the whole user object, but we don't use all the properties on it. Yeah, good call. Yeah, you don't want to put the password on a JSON Web Token. Yeah, that would be bad. Yeah. I mean, let's just think about it. What does it mean to even sign in?
We need the username and password.
We need the username and password because, I mean, think about it. You're on a sign-in form. Don't you type in your username, your email, password? Okay. What do you think is happening with that? How do they know? Yeah, what is it checking? Like, what do you think? Like, what's being checked?
If your
It just
name
has the password,
or
yeah.
password exists somewhere.
Okay, so there's a user with this username in the database. Okay, cool, I found you, you're in the database, but how do I know you're you? Anybody could have knew your username. How do I know you are you?
Your password is unique to your name.
Okay, so password, let's talk about password. What am I looking at your password at? Look at this line right here, right? I'm gonna compare the password you sent up when you signed in to the hashed password that this user has in the database. And if they match, you must be who you say you are, right? Because I already found you by username, so you exist, and your password matched what was in the database if I hashed it again. So either you got this person's password or you are who you say you are. So that's what we're gonna do. Love the way you think. So let's do that. So first let's find the user. So user would be await prisma.user.find unique, and you put an object in there with a where property. I need an async. So I'm saying prisma.user.find unique where, and I can say where username is going to be rec.body.username. You got to send me a username if you want to sign in. I'm not going to pass password here. The reason I'm not going to pass password here is because it would not find the password. Like, because the password that you're sending up on sign in is a plain text password, but the password that's in the database is a hash password. They would never match. So I can't put password here. You might say, well, why don't you just hash the plain text password and search the database for a combination of a user that has this username and that hash password? Yeah, I could do that. But then we'd have to go back to indexing, and I would have to put an index on a password, which would probably be really expensive in every way you could think of. So it's probably not the best use case to index a password, something that changes frequently, and there's a better way to do it, and that's why we made that helper function. So we're not going to query for a combination of a username and a password. Instead, we're just going to see if there's a user period with this username. We're not saying it's you yet. We're just saying, is there even a user with this username? That's first step. Second step is like, okay, I'm going to look at that user's hash password and see if it matches the password that you passed me in plain text. If those things match when they're both hashed, you must be who you say you are because you had the right username and you had the password that matched that username. So that's what we're going to do. So I'm going to say const is valid, and I'm going to say await compare passwords, and the first password is the plain text one. So I'll say rec.body.password, and the second one is the hash, which would be user.password. Okay. Then I can say, oh, if not is valid, then you just knew someone's password and tried to sign in, but you didn't have the right. Someone's trying to hack your account. That's what's happening. Or you just fat fingered your password. One of the two. So if not is valid, then I can be like, yeah, get out of here. Res.json 401, res.status 401, which means not authorized. And I can send back a message if I want to. Nope. And I'm going to return because I don't want it to continue. But if it is valid, cool. You are who you say you are. Everything checks out. Let me go ahead and create you a token right quick and send you that token back so you can get access to the rest of the API.
Just one question. When we are doing the compare password, why we need to do async? Because it should be in the memory, right? The comparing or...
Yeah, so that's a great question. So why do we need to do async? It basically comes down to how bcrypt is designed. So bcrypt has 3 different ways to do these methods. You can do them synchronously, but you specifically have to say like compare sync or hash sync, and then it's synchronously. If you don't do that, you'll get the asynchronous version, which by default returns a promise. Both of these return a promise. Or you can just pass a callback and do it that, old school that way, but I'm not doing that. So I'm going to use the async await because this is a promise and this is a promise. But yeah, you're right. You can do it in memory if you pass sync. Yeah.
Another question is in the Prism, while we are doing the where clause.
Yes, the where clause here.
We are directly taking the value from request body.username. Does it secure the? Taking the.
You know too much. So no, there is no input validation happening right now on the body. That is something that we're going to talk about tomorrow. But yeah, right now, no, we're trusting the user.
Some of the ORM does the input.
Yeah, some ORMs do input validation. I think you can I think there's some things you can do in Prisma like to do that. Like I know like in Mongo you can write you can write middleware in Mongo schema to like validate different things. I know you can do that stuff in like SQL. Like there's some things, but I don't know of a mechanism in Prisma that allows you to do that. But regardless, we would probably validate inputs in a middleware anyway. We would just like throw in a middleware on the route somewhere that would validate those inputs before they even got to the handler. Because like my philosophy is like, I want the handlers to not even think about auth. I don't want them thinking about validations. I don't want them thinking about inputs. I just want them to, by time they execute, they can assume everything is right because all the middleware before them did all the other stuff, right? That way you're not repeating the logic in every single handler that you have. Like check to see if the user's there, check to see if the input's good. Like you're gonna do that copy and paste over every single handler. Whereas you just put that in one middleware, then that's just the middleware's job and the handler's protected. So when the handler was called, it was a correct API call. And not, you just separate your business logic from like the other logic, basically.